Hello everyone. In this video presentation, we will go over how to set up the hardware and software configurations for a CK3C in order to command a direct PWM signal and read sinusoidal feedback through CK3C supported stack accessories. In the ensuing sections, we will learn a brief hardware summary about the ACC-8FS and ACC-51S functionality with the CK3C, how to configure the jumper settings for the individual accessories used, how to properly stack the accessories, what power supplies and connectors are needed, what PMAC structure settings pertain to the accessory AFS, and what an encoder conversion table looks like for the accessory 51S. The accessory 8FS is a 4-channel direct PWM stack breakout board for the CK3C and Clipper family product lines. It is used to control digital amplifiers that require a direct PWM control signal. It uses a mini D 36-pin connector to output its control signal. This board is mainly used for applications where the CK3C is performing both the commutation and digital current loop closure for brushless motors. The accessory 51S can be stacked on top of the CK3C to provide 4 channels of sinusoidal encoder interpolation. Unlike typical Gate 3 products, the accessory 51S cannot perform interpolation in hardware as certain other accessories. However, software arctangent extension can be enabled to process the sinusoidal data from a PMAC 2 style IC such as the accessory 51S. The accessory 8FS does not require any specific jumper settings. However, for the accessory 51S, the factory default jumper settings are displayed in this table from the accessory 51S manual. The jumpers are indicated by the E nomenclature from E1 to E14, and the encoder connectors are labeled J9 to J12 on the board. In this picture, you can see a few of the jumper and connector callouts. When using an accessory 8FS in combination with the accessory 51S, stacking order is essential for proper use. The first accessory on the stack must be the accessory 51S due to its connector cabling limitations. The accessory 8FS can then be stacked on top of the accessory 51S. The pictures displayed indicate how the pins from the accessory boards must align with the female box header slots on the CK3C and on the accessories themselves when stacking additional boards. If intending to command a direct PWM signal or reading sinusoidal feedback, the user must wire the plus 5V power supply for logic power to the device as well as the plus and minus 12V power supply for analog I/O power. Plug in your PWM cable to the accessory AFS channel you wish to use for commanding the direct PWM signal to the digital amplifier. On the PCB for the accessory 8FS, J15 indicates the first channel, J16 is for the second channel, and so on. Next, connect the provided ribbon cable that comes with the accessory 51S from the J7 port on the accessory 51S side to the J3 port on the CK3C side as seen in the picture displayed. Note that the longer end of the cable contains pass-through connections for DAC outputs and other amplifier pinouts. Only the shorter length box header connection is used in this example. In these next few slides, we will be configuring the software settings for motor 1 in our example. From default settings, motor1.enctype equals 6 is the only unique parameter that needs to be set in order to output a direct PWM signal from the accessory 8FS. This parameter will be placed in a global includes file in your project that contains all your motor-specific settings. Here we have an example encoder table configuration for setting up a sinusoidal encoder. There are a couple parameters I'd like to highlight in this encoder conversion table setup. The first one is enctable1.type equals 4, which enables software arctangent extension. Second is enctable1.penc. This parameter points to the status register where the quadrature data is read from. Next, enctable1.penc1 is set equal to sys.pym plus the address offset to the register that contains the sign input for the corresponding channel. EncTable1.index5 equals 1 specifies you are using a Gate 3 style IC to process the source data. And lastly, EncTable1.scaleFactor equals 1 for scaling and raw counts. Now that the encoder table is set up, there are two final parameters to set before viewing the encoder feedback in the position window. The first is gate30.channel0.enControl equals 7 or 3. This will specify the encoder decode control as well as the direction sense of your motor. All that is left is to set motor1.servocontrol equal to 1 to activate your motor so that you can now see the live encoder feedback in your position window. Now that we've discussed all the main software settings that pertain to the accessories being used in this example, I'd like to point out just a few more things. Some final remarks I'd like to mention are, although EncTable1.PEnc points to the status register, PMAC automatically offsets from the status register to the servocapped register in order to read the quadrature data when software arctangent extension is enabled. For additional info configuring other parameters, please review the CK3C manual and the appendix section for full motor setup depending on the accessories being used. Since the example in the video does not provide full motor setup, make sure to read over the highlighted sections in the picture displayed. We hope that this video has helped give you an understanding for how to set up an accessory 51S and an accessory 8FS with your CK3C. If you have any questions, please contact your local Omron representative.